Alright, so we're going to figure out how to do these complex fractions. So the first thing you want to ask yourself is what's the common denominator between all three pieces? Now, just to remind you that here we have three denominators that we got to deal with. We got this and we got these two. Okay? And so ultimately what we're going to look to do is multiply top and bottom by the common denominator between all three. Common denominator between all three is? PQ. So we're going to multiply top and bottom by PQ here, PQ here, PQ here. Now, what happens when we do that? This P and this P cancel. We'd be left with 3Q. This Q and this Q cancel. We're left with 2P over this P cancel, this Q cancel. We have 9Q squared minus 4P squared. Bless you. Okay. Now, what are you going to do there? Factor the bottom piece. 3Q minus 2P over 3Q minus 2P, 3Q plus 2P. This and this cancel, leave me with 1 over 3Q plus 2P.
Are you going to be upset if that's not how we do it on the test?
Now, I was getting ready to bring this up. Now, some of you all are going like this. Some of you are doing 3Q over PQ minus 2P over PQ, and then doing something like, and then you're basically just multiplying by the reciprocal.
Yeah.
And so you're getting 3Q minus 2P over PQ times PQ over, it's the same thing.
Right. So you don't
I don't care.
Okay.
As long as you're getting to the right answer and you're doing it functionally correct, it doesn't matter. If you want to find the common denominator between all of them and then flip it and do that, that doesn't make any difference.
How did you get plus 2p?
This is the difference of two squares. So it's 3Q minus and then 3Q plus. Yep, and then it cancels. So again, I mean, I saw some of you doing it this way, and that's perfectly fine. Okay, I mean, I personally don't think it's as good, but it's a personal preference. Okay, what's that? All right. All right, moving on. Now here, common denominator is 2 and t plus 4. Now here, you're going to multiply through by 2 and t plus 4. That's your common denominator to each one. Okay. So what happens? T plus 4 cancel. You're left with 2 plus. Here, the 2 and the 2 cancel. You're left with 1 t plus 4. And then here, the 2 and the 2 cancel, the t plus 4 to t plus 4 cancel. You're left with only 3. Let me pause there for station identification. We're going to distribute 2 t plus 4 equals 3. T plus 6 equals 3. T equals negative 3. Now, when you get your answer, if you are not taking your answer and plugging it back in to make sure that you're not getting 0 in the bottom, you're going to get lucky most of the time. There'll be a few times where you don't get lucky and you end up marking it wrong. Okay? And you'll swear you knew what you were doing. When you plug in negative 3 plus 4 is 1, so we're good. We don't have to worry about it. But you always got to double check. Okay? Any questions on that? Going once? Going twice?
Don't you have to put it in the squiggle?
as a solution set. Yes, sir. Good job. Any other questions? All right. Common denominator. X plus 2, x plus 3. I'm going to multiply 3 by x plus 2, x plus 3. 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 Now, x plus 2's cancel. X plus 3's cancel. Both of these cancel. So what are we left with? 5 x plus 3. 3 x plus 2 equals x. Okay, any questions on that? Yes. Let's pause here. All right, now we are going to distribute. Oh, wait. This is even on video. This is going to be perfect. See the rainbow. All right. 5x plus 15 plus 3x plus 6. Some of you are going to show it to whoever said that. And they're going to be mad at me probably, but just know I love you, partner. 8x plus 21 equals x. So subtract 8x, 21 equals negative 7x. It's going to work. Divide by negative 7, x equals negative 3. And again, the one thing I see there is people get done, they get so excited, they're like negative 3, feeling real good about themselves. Okay? Solution set, yeah. If you plug in negative 3, observe. If you plug in negative 3, negative 3 plus 3 is 0, and you can't do that. So this answer is no good. No solution.
Can we just put like x equals negative 3 and put a line through it? Would you understand that? So it has to be 0 and then the line. Or can we write no solution?
You can write no solution too if you want to.
Okay.
Bless you. All right, so now we're moving into this area of what we call literal equations. So literal equations are equations where you have to solve, but you don't have any numbers. And this is always a lot harder for people than regular problems are, because notice if I told you x plus 8 equals 10, and I said solve, you wouldn't have to use any complicated math to figure that out. You just kind of look at it and go like this. X is 2. If I say show your work, you go like this. Yeah, here you go. X is 2. Show your work. All right, fair enough. 2 plus 8, 10. Okay. That is clearly a 10. That is a 10. This is a W. Figure them out. All right. Now, so for a problem like this, how do you go about solving for x? Well, the idea is you got to get rid of the y. And some of you are going like this. Just erase it. It'll go away eventually. Okay? How do you get rid of the y? Subtract y from both sides. Subtract y. Get x equals z minus y. Now, the problem that most of you will find as you start working these literal equations is that you get answers that don't look very good. Okay? Most of you have gotten pretty good through your life of looking at answers and determining which one looks good. That's like FCAT 101. How do I pass standardized test? Learn to evaluate answers when I'm completely clueless. Pick one that looks right. Okay? This doesn't look good, but it is right. And they start looking worse as you go along, by the way. Okay. So, how do I solve this one? How do I solve ax plus by equals c? Subtract by. So the first thing we want to do is move the by over. So we're going to do that by subtracting by. So we're going to get ax equals c minus by. Divide by a. Divide by a. You'll get x equals c minus by over a. Luke, what's wrong?
It just looks disgusting.
Yes. For the first time in my life, somebody has said they like these. They don't have numbers. Most people go like this. Give me numbers any day of the week. Like, numbers are so much easier to deal with. Each his own. Okay? All right. This one is a lot harder. But that's the point. You got to recognize that the x comes out.
Wait, you skipped one.
P equals 2L plus 2W. Didn't skip anything. What are we solving for? All right, how do I solve for W? Move the 2L over. So subtract 2L, subtract 2L. P minus 2L equals 2W. Divide by 2. Divide by 2. The reason why I like this problem, and the reason why this one's different than the other one is, earlier today a student was saying that they get terribly confused because they never know when to quit. And what they said to me was, when I want to keep going, you always stop. And when I want to stop, you always keep going. Okay, well, you just got to know when to keep going and when to stop. At this point, you're supposed to stop. And she's like, no, I kept going. Cancel out the 2's. It's got to be in parentheses in order for you to do that. So some people go like this. Well, fine. If you cannot factor, you cannot reduce. So since the 2 does not factor out, you cannot reduce that. Okay? So the final answer is simply B minus 2L over 2. And you stop. Okay? Let's pause here for station identification. All right, so go back to the one that I was just currently looking at. I don't know what's wrong with this stupid thing, but hope it's working. All right, how do you solve for x? For this one, you have to factor the x out. So you're going to get x, a plus b equals c. You'll divide by a plus b. You'll divide by a plus b. You'll get x equals c over a plus b. Now the question that should come up is, how do you know when you have to factor? Say it a little bit louder. We're going to put you on the internet. You'll be famous. Come on. Say it. If there's 2 of the same terms you're solving for, that is an idea that you have to factor. When there are 2 of the same terms that you're solving for, then you know you have to factor. So let's fast forward to this one. What are you solving for? You're solving for big M, right? So you have this one and you have this one. There's 2 of them. So at some point, we better invoke factoring. All right. So at some point, we had best invoke factoring. So let's multiply both sides by, we have U equals big M V over big M plus little m. We're going to multiply both sides by big M plus little m. Now, some of you are going like this. Ain't that 2m? No, they're different. One's a big M, one's a little m. That's entirely different. Big M plus little m. Now, notice here they cancel. So you're going to get big M V. Now, this is big M U plus little m U equals big M V. What are we solving for? Big M, yes. Okay. We're solving for this piece and this piece. If it shows up twice, what do we have to ultimately do? Shows up twice, we ultimately have to factor. So move this over by subtracting big M V, or excuse me, big M U. This is a U. Okay. So we have little m U equals big M V minus big M U. Factor out the big M. V minus U. Divide by V minus U. Divide by V minus U. And that's your final answer. M U over V minus U. Who got that? Who got that before we started? All right, let's pause here. So a problem like this, very similar to the one we just saw, except the letters aren't quite as confusing, hopefully. We'll multiply by S plus R. We get AS plus AR equals SK. We're solving for S, right? Subtract AS, AR equals SK minus AS. Okay. We're solving for S, so factor out the S. AR equals S times K minus A. Divide by K minus A. Divide by K minus A. And you'll get AR over K minus A. Same thing. RA is fine. Yeah. The question was, can it be AR or can it be RA? And the answer is yes. Commutative property multiplication. Just tell her commutative property of multiplication. And if you say it just like that, you're going to sound so smart, no one will argue with you. No.
For real, she gonna be so good.
All right. So for this one, you channeled your inner Sesame Street. You multiplied by ABC. Now what happens? The A and the A cancel, the B and the B cancel, the C and the C cancel, leaving me BC plus AC equals AB. And what are we solving for? B. Move this to get the B on the same side, so subtract BC, subtract BC. AC equals AB minus BC. Factor out of B, you're left with A minus C. That's a C. I don't care what it looks like. All right. Subtract by A minus C. And you get AC over A minus C equals B. Any questions?